Hello everyone, welcome back to the video lecture series of Basics of Electrical and Electronics Engineering. I am Sajitha and today now we are going to discuss about the full wave rectifiers. In the previous class we discussed about half wave rectifier and its operation and its construction. So, in the half wave rectifier, we clearly saw that there is only one half of the AC cycle which is going to be rectified. So, if half wave rectifier is going to rectify only one half, then what about full wave rectifier? Yes, a full wave rectifier is going to convert both the cycles of an AC into a pulsating DC. So now let us discuss in detail about the various types of full wave rectifier and its advantages over the half wave rectifier. A full wave rectifier In a full wave rectifier, the current flows through the load in the same direction for both the half of the AC input. This can be achieved only when there is two diodes which are working alternatively. So in the half wave rectifier we saw that there is only one diode and that is going to function only during one half of the cycle. Whereas in the full wave rectifier we can say that there are two diodes which are going to work alternatively, and for one half cycle one diode supplies the current to the load, and for the next half cycle another diode works. It is generally classified into two types. One is center tap full wave rectifier and the other one is full wave bridge rectifier. Let us discuss both the type of full wave rectifier in detail. Center tapped full wave rectifier. As the name suggests, you can see that in the transformer, in the center tapping, the load R is connected. It has two diodes, diode D1 and diode D2. Now, during the positive half cycle, the diode D1 conducts and the diode D2 is said to be in off state. Whereas during the negative half cycle, the diode D2 conducts and the diode D1 is said to be in off state. Here, one important thing which is going to be noted keenly is that during both the half cycle, the flow of the current is in the same direction. The arrow mark is indicated in the diagram where you can see that in RL, the current always flows from positive terminal of the R load to the negative terminal of the R load, meaning that there is no absolutely change of current flow. During positive half cycle and the negative half cycle, you can see the flow of current directions. It starts from the positive of the transformer and then goes to the positive of the diode. From the negative, it reaches the positive of the R load and then it reaches the negative in the positive half cycle. Whereas in the negative half cycle, the current direction reverses but the flow of current is in the same direction as that in the positive half cycle for the load. The current flows from the negative of the transformer to the positive and then to the positive of the diode to the load positive and then to the negative. So hence in both the cycles we can see that the current flows in the same direction in the R load. Now coming to the full wave bridge rectifier. So from the circuit, what is the primary difference between a center tapped and the full wave bridge rectifier? Yes, the center tapped there were only two diodes, whereas in the full wave bridge rectifier there are four diodes. So these four diodes are going to function in such a manner that during positive cycle, that is from 0 to 180 degree, diode D1 and D2 is going to conduct and the other two diodes D3 and D4 is said to be in off state. Whereas during the negative half cycle, we can say that the diode D3 and D4 will conduct and the other two diodes are said to be in the off state. In this type of full wave bridge rectifier circuit, though there are four diodes applied, Two are said to be in on state and the remaining two diodes are said to be in the off state or in the open state, thereby improving the efficiency and also the output of the circuit. Thank you.